Okay, Bismillahirrahmanirrahim. Hi everybody, my name is Ibrahim Baabad. Today I am going to show you the procedure of testing of my thesis. First, I will talk about the dataset, the pre-processing of the dataset used in the two stages. Then we will move to the testing part. First, as you can see, the dataset used in the row has 1524 instances and more than 16,000 of features. So this the column is number is 16,380, and here is the label. The second column is the label of a class. If it is 1, that means it is ransomware, and if it is 0, it will be goodware. So this is an example of a goodware instance. Here the same dataset, but after the first stage of pre-processing using the Excel program software. So here we have some changes. You can see here this is the level. It means 1 is the ransomware and 0 is goodware. Here is the ransomware family, and here is the number of features. So here it is 16,380 feature we have. So we will do feature selection process to get to this. So here this is the dataset after the final dataset after the pre-processing, the second stage. Here we have the same number of instances, but we have only 26 features that included the label, which is ransomware or goodware. Also, we have changed the numerical values from 0 to become no and 1 become yes. Also, ransomware, it was the 1, now it is ransomware as a nominal value, and 0 becomes goodware as a nominal value. This is the CSV file that transferred to a.arff file through Weka. Now we will see, inshallah, as described in the thesis document. So here we see the structure. This is the first. After the first stage, the dataset contains the ID, then the features, and until the last feature with the family and label. But after the secondary stage, it has no ID, just the 26 features with the family and the label with nominal values. Now we will move to Weka. I use the Weka program for pre-processing dataset, like I use the filters for randomization, and then I use it to perform the feature selection process. through an algorithm that is correlated based feature select correlated based sorry correlated based subset feature is the correlated based subset feature algorithm. It depends on a subset of low and intercorrelated features between them, but they have highly correlation with the class. So this is the subset that the algorithm selects. They have no or low intercorrelation between them, but with the class they are high correlated with the class. So this is the 26 features that we have used, that the algorithm selected through the Weka program. So here is the Weka. We have to enter the Explorer. Then we will open file. It is but in the .txt file. This is the ransomware. Set. Now it is reading from the file. We will check out the details and selected the details. So we have here the activities, all the activities. We have 116 as we see 16,380, and here the level we have around 500 of ransomware and like 900 of goodware. So after that I applied some filters like for randomization. Okay. After this I do the selected details and I choose the correlated based feature subsets algorithm. Then we will use the full training set, and we have a class which is the last level, and then we'll start the procedure. Now it is performing the feature selection. While this is happening, we will move to massive online analysis software, which is a library for manipulating stream data mining techniques. And as we specified, we will use the classification technique. Maybe it takes some time to open. here it is finishing the selection, the feature selection process. So this is the selected feature. So it was 16,000 or more, and now it is only 26 features. It is only 26 features. So here is the massive online analysis software, and we will use the classification. Now we want to configure the massive online analysis to be compatible with the dataset preprocessed. So we'll use the task of classification, which is the evaluate sequential delay. That means this task, in this task, the classifier will test first and then will be trained. So this becomes this is help to fast procedure for classification, and we need to determine the k after number k of examples. So after 1000 it will do the classification, and the initial training window will be 100, and we will enable the train on initial window, so we mustn't miss anything, and we will train in batches. Also the frequency, sample frequency will be 10, because we only have around 1500 instance, and the memory will be checked after the 10 instance. The learner I will use as an example the extremely fast decision tree, which is a holding tree, which is the extremely fast decision tree. And here I will don't show anything. The stream, it will be not generator. We will use the file that comes from the Weka tool, which is our dataset after pre-processing, and change to the .ar WF file, just to this so the stream not generated. Let me check again. This one, the AR WF file stream. So we will browse for the file or file. This one that comes after feature selection, and then we will use care. So now the configuration is done. Now we are ready to run the event, which is the extremely fast decision tree, and we will see the accuracy here and the time. First, the accuracy, it is 9941, as we get in the thesis. Let me show you the results. So we will do 10 tests as recommended by a paper to be sure for the results of the program. Then we will calculate the average and the standard deviation. Also we'll see the monitor the time, which is the latency. Here it is 260 milliseconds, but if we run it again it will change. So we need to test 10 times to record all of this, and finally we will calculate the average, which is here in our case is 66 milliseconds. And I have another six algorithms, which is string data mining, classification algorithms. In the same way, I am doing the testing for the accuracy and time latency for our data set, which is an open source data set. So this is all things I want to show you in this uh, show or in this presentation. Thank you for listening and see you later. Assalamu alaikum.